functions. All right, so the first thing is that we are going to be dividing using synthetic division. So number 8, we have 2x to the 4th minus 5x cubed plus 7x squared minus 3x plus 1, all divided by x minus 3. So obviously we did stuff with this last year, so hopefully a lot of it is review. But when we do synthetic division, we put this number in a little box in the corner, but with the opposite sign of whatever it is. So it's going to be a positive 3 in this box up here. And then as long as these terms are in order, we copy the numbers down. Remember, if there's a term that's skipped, we have to put a 0 or you will not get the right answer. So we've got 2, -5, 7, -3, 1. We bring down the first number, then we multiply it by what's in the box. So multiply by 3, we get 6, minus 5 is 1, times 3 is 3, add 7 is 10, times 3 is 30, minus 3 is 27, times 3 is 81, plus 1 is 82. Now, I'm not done. I have to write it, the summary statement with the answer in fraction form. So that means that I have, remember, if this was x to the 4th, this is going to be x cubed. So I have 2x cubed plus x squared plus 10x plus 27, and then plus whatever the remainder is, which is in that box down there, 82 over x minus 3.
Not fixed.
Yes.
So we removed the 1x because it's x minus 3?
Yeah, because we're dividing technically by an x at the same time. You just don't see that process happening. So it's it's almost like you're factoring an x out of everything, essentially. Is like more or less what's happening.
Okay, that's why.
And remember, synthetic only works when
Did you try to add this?
the bottom is like just an x by itself and then minus or plus a number.
Did your mom?
Like it doesn't work any other way. If it's anything bigger than that, we have to use long division. 10. 3x to the 4th plus x cubed minus 4x squared plus 9x minus 3, all divided by x plus 5. All right, so in this top corner, we put a -5. I don't have any terms missing, so I can just copy the numbers down. 3, 1, -4, 9, -3. Did you fix it?
Kind of.
Bring down the 3. Times -5 is -15. Plus 1, -14. Times -5 is 70. Minus 4 is 66. Times -5 is -330. Plus 9 is -321. Goodness gracious. Times -5. 5, 10.
1605.
Yep. And then minus 3, so 1602 would be the remainder. So again, this was x to the 4th, so that means that now it's x cubed. So we have 3x cubed minus 14x squared plus 66x minus 321. And then that remainder plus 1,602 over x plus 5. Is this ringing a bell from last year?
Yep.
Awesome.
This was like the beginning of last year, wasn't it?
No, chapter 5. I mean, it depends on what you define as the beginning, I guess. Beginning being like right before Christmas, then yes. Like it was the last thing we did before Christmas.
Semester.
Yeah, so I was like, it depends on if you define it as beginning as just like anything first semester or like first quarter. 12, x to the 8th minus 1 over x plus 2. So what's going to happen with this one?
Put zeros.
Yep, so I put negative 2 up here in the corner. I start with 1. Now that's x to the 8th. So x to the 7th gets a 0, x to the 6th, x to the 5th, x to the 4th, x cubed, x squared, x all the way to my constant term. So there's 1, 2, 3, 4, 5, 6, 7 zeros in between the 1 and negative 1. All right, so bring down the 1 times negative 2 is negative 2. Obviously, all these are zeros, so negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. Negative 8 times negative 2 is 16. 16 times negative 2 is negative 32. Negative 32 times 2 is 64. 64 times negative 2 is 128. Nope, negative 128. Negative 128 times negative 2 is positive.
56.
Thanks. 256 minus 1, 255. So then we've got, this was x to the 8th. So this thing went from being something that was nice and short and simple to this huge long thing. So I've got x to the 7th minus 2x to the 6th plus 4x to the 5th minus 8x to the 4th plus 16x cubed minus 32x squared plus 64x minus 128, and finally plus 255 over x plus 2. So obviously that one was a little dramatic with the amount of zeros we had to add. They normally don't give you something that's that crazy, but just keep that in mind in case. All right, the remainder theorem is the next thing. So they ask us to find the remainder when f of x is divided by x minus k. So what they do is they give us something like 14 f of x is equal to x to the 4th minus 5, and they tell us that k is equal to 1. So the remainder theorem says plug whatever k is into x and f of x, and that's going to be your remainder. So f of 1 is equal to 1 to the 4th minus 5. So that ends up just being negative 4. So my remainder on this problem is negative 4.
So this is just substituting a variable in?
For this one, yeah. The remainder theorem is just
So
plugging it
what's
in.
K?
1.
What is k?
Oh, it would be like x minus k when you divide by it. So if all you care about is the remainder, then I can take, so like what you would have been given is like, say with this one up here.
Yeah. 2 is k in that problem.
Like if I plug in, yeah, well, negative 2 is k. Because k would be opposite sign of this. So if I ran the remainder theorem on this problem, then I would end up with f of negative 2 is equal to negative 2 to the 8th minus 1. And you would end up getting this 255. all that this is giving you is the remainder part of the problem. It's not asking us for anything else.
So is there a benefit to having the whole problem written out and like actually dividing the problem? Because it, like on the last one, on 12, it's much simpler to look at before we divide it.
It really just depends on like the context of what it's asking you for. A lot of times we're using this for other things, like to be able to like factor it out or whatever. This is really just like the synthetic division in and of itself. Is it beneficial? Not really. But it's the intro leading you to being able to factor stuff out, because we can keep factoring this down when we have an idea of what our zeros would be using synthetic division.
So is that gigantic thing equivalent to the thing that's above? Are they the same?
No, because I divided it. This
Wait.
was divided by this. So if I multiplied this whole thing by x plus 2, then yes.
But what I mean is like you already have, like if you.
Okay,
It's-
yes,
it's
this
already
right
there.
here is equivalent to this,
Okay.
but not to the top.
No, but the
This
whole
would need to be
thing-
multiplied by x plus 2 to be equal to the
The
top.
whole red thing is the whole.
Is
left
equal
red.
to the, yes. Yes. So yeah, this part in and of itself isn't necessarily overly useful, but the process of synthetic division is useful for factoring so that we can graph and know things about our graph much quicker, because we don't just know what the graph of that looks like in and of itself.
Yep.
So that's kind of what it's like leading us to. Another one of these, 18 f of x is equal to x to the 5th minus 2x to the 4th plus 3x squared minus 20x plus 3, and k is equal to -1. So f of -1 is equal to -1 to the 5th minus 2 times -1 to the 4th plus 3 times -1 squared minus 20 times -1 plus 3. So -1 to the 5th is just -1. -2 times, that'll be a +1, is just -2. 3 times -1 squared is +1, so plus 3. -20 times -1 is +21, and then plus 3. So basically, this -1 and -2 cancel with the +3, and so we end up with 24 as our remainder to this problem.
How'd you get a positive
20.
Sorry, I was like genuinely confused. I didn't think it was a mistake.
Nope, it is.
Is that okay?
Looks like it. I'll write it up there after. I put the cookie in the cookie jar. That's what really matters. To fill the cookie jar. Getting closer. Huh?
I didn't even know there was a cookie jar.
Is it still 10? Do you have to fill it?
Wait, is it 3D?
When all the classes together fill the cookie jar, and everybody gets cookies.
Is that a 2D object or a 3D object?
I mean, I guess it depends on your definition of, I would say 3D, but I guess it depends on your definition of that. How you look at it. All right, so yes, this would be 23, not 24. All right, factor theorem. We're using this to tell us if something is a factor of the other, which is going to be more useful to us going forward. But again, it puts everything kind of together for us. So number 20, they give us x minus 3, and then we have x cubed minus x squared minus x minus 15, and we're trying to say if this first polynomial is a factor of this polynomial. So to do that, we have to take and basically find k and plug it in. If it's equal to 0, it is a factor. If it's not equal to 0, then it's not. And essentially, then you know what your remainder is. more or less. If either of any of these problems up here had come out to be 0, we would have known that that would have been a factor. Or, well, a 0 technically. But written in this form, it would be a factor. So k is equal to 3, because it's the opposite sign. And then we plug in 3 over here. So 3 cubed minus 3 squared minus 3 minus 15. So I've got 27 minus 9 minus 3 minus 15. So that's negative 24, negative 27. 27 minus 27 is 0. So yes, this is a factor.
Sure enough.
24. X plus 1, and we've got 2x to the 10th minus x to the 9th plus x to the 8th plus x to the 7th plus 2x to the 6th minus 3.
That's a lot of numbers.
All right, so what is k?
One. Negative.
Negative 1, it's opposite sign when it's written in this form. If they just say straight up k is equal to blah, 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 then obviously it's whatever that is. But if it's in factor form like this is, it's opposite sign. All right, 2 times negative 1 to the 10th minus negative 1 to the 9th plus negative 1 to the 8th plus negative 1 to the 7th plus 2 times negative 1 to the 6th minus 3. All right, so we have negative 1 to the 10th. That's just positive 1. So we've got 2. We've got negative 1 to the 9th, which is negative, but times a negative, so that's going to be plus 1. Negative 1 to the 8th is going to be plus 1. Negative 1 to the 7 is minus 1. Negative 1 to the 6 is positive 1 times 2, so we've got a plus 2. And then minus 3. So I've got 2, 3, 4, 5, 6, minus 4. So I get 2. So that means no, it's not a factor because it's not equal to 0. So if it's equal to 0, it is a factor. If it's not, then obviously it's not, and that would technically be telling you your remainder. All right, next thing. Find the polynomial function with leading coefficient 2 that has the given degree and zeros. So 28. They tell us it's degree 3. And it has negative 1, 3, and negative 5 as zeros. And it has a leading coefficient of 2. I usually don't worry about that until I get to the end because it can be too confusing. So this is essentially just a slight modification of the last problem we did yesterday. So we have, this would be like x equals each of these numbers. So when we move them over, the factors would be x plus 1, x minus 3, and x plus 5 that are being multiplied. So then I just FOIL. So I get x squared minus 3x plus x and minus 2x minus 3. Then multiply that times x plus 5. So I've got x cubed plus 5x squared minus 2x squared minus 10x minus 3x minus 15. So then combining, I've got x cubed plus 3x squared minus 13x minus 15. Now, it said I have to have a leading coefficient of 2. Any idea what I might need to do that?
Subtract the x cubed.
Stick it in front of the x.
Multiply everything by 2.
Multiply everything by 2 so that I end up with a 2 in front of it all. So I'm going to take this whole thing and multiply it by 2. And so I end up with 2x cubed plus 6x squared minus 26x minus 30. So that would be your function. Now, I could have put the 2 out front to begin with, but I usually just like to deal with it at the end because it just makes the numbers easier to deal with if I wait till the end.
Okay, I have a question.
I might have an answer.
So, the very first one where it's the x plus 1 times x minus 3 times x plus 5, if you just like how we do when we remove a 2 from it, where you put the 2 in the front, would that just be also the answer? Like, would that be the same, like, graph?
Like if I did this?
Yes.
Yes. But that's not written in this notation that it needs to be written in for your final answer. So yes, it would be the same graph, but that would not be the correct answer. Because you did no work to do that, other than just set it up. But yes, ultimately I could have started with it there, or I could do it at the end, as long as you don't forget about it. If you feel like you're inclined to forget, probably write it first. But all right, 34 and 36 want us to use the rational zeros theorem to write a list of all potential rational zeros, then determine which ones, if any, are zeros. So 34, f of x is equal to 3x cubed minus 7x squared plus 6x minus 14. All right, so if you remember this from last year, we do the factors of the last number over the factors of the first number to find all possible zeros, and then we're ultimately determining which ones actually are zeros after that. So we have the plus or minus 14 over plus or minus 3. Now, I'm not going to say it every time, but just know that all of these are plus or minus when I do this. So what are factors of 14?
1, 2, 7, 14, 2.
Yep. And then 3 obviously is just 1 and 3. So I need to write them all out. So I have 1, 2, 7, 14, and then I do them all over 3. And remember, in the event that anything reduces, this one won't, but that would reduce to something we've already written, we don't write it again. Everything only gets written once. So then we've got 1/3, 2/3, 7/3, and 14/3.
And it's okay to leave them as plus or minus. You don't need us to write them all out separately.
Yeah, no, that's fine.
Okay.
These are already tedious enough. We don't need to make them even
Right.
worse.
Thank you.
All right, so at this point, does anybody remember what my next step was from last year?
Calculator.
Yep, we're going to plug this function into the calculator and then look and see which one might possibly be the zero. So remember, we just graph it. If you have a stat plot on from whenever, you're going to need to turn that off, or it's going to throw off your graph.
Can I go grab my calculator?
Yeah.
How do we do this?
So once you have it typed in, hit Zoom 6 for Zoom Standard. So once you graph it, you're looking on the graph to see approximately what looks like it could be a 0. So out of all the numbers on our list, plus and minus, which one looks like it could be that value?
Let's do -7/3.
Yep. So most likely 7/3, so that's the one we're going to check. Now remember, there may be times where there's multiple values in here that, like, it could be off of your list. This one, obviously, there's only one that really fits in that criteria, but there could be multiple, so you may need to write down multiple and check them in between. So once you do that, we put 7/3 in the box, and then we do synthetic division. Again, as a reminder, if a number is missing, we've got to put a 0 in there. So we've got 3, -7, 6, -14. Bring down the 3. 3 times 7/3 is 7. -7 is 0. Times 7/3 is 0. Plus 6 is 6. Times 7/3 is 14. -14 is 0. So that right there, as soon as it ends in a 0, that tells me that that is a 0. So 7/3 is a 0. Now, the factor, if we were going to write it, it's not asking us for this, but the factor would be x minus 7/3. Now, these ones are not asking you to continue the problem, but we could obviously keep finding the other factors that get us to this point, but we don't need that in this section. I think that's like next section or something. So that's all you have to do on this one for these problems. All right, let's do one more of these ones. 36. F of x is equal to 6x to the 4th minus x cubed minus 6x squared minus x minus 12. So I've got factors of 12 over factors of 6. So what are my factors of 12?
1, 2, 3, 4, 12.
1,
6,
2, 3, 4, 6, 12. Yep. And then what about 6?
1, 2, 3, 6.
All right, so this one obviously is going to have a little bit longer of a list most likely, but again, if anything's repeated, I don't write it multiple times. So I've got obviously all the numbers, 1, 2, 3, 4, 6, 12. Then I've got each of these numbers over 2, so I've got 1/2. Now 2 over 2 is just 1, I've already got that. Then 3 halves. 4 halves is just 2, I've already got that. 6 halves is 3, already got that. 12 halves is 6, already have that. So then I'm doing each of these numbers over 3, so I've got 1/3, 2/3, 3 over 3 is 1, 4 over 3, 6 over 3 I have, and 12 over 3 I have. So then everything over 6, I've got 1/6. 2 over 6 is 1/3, already have that. 3 over 6 is 1/2, already have that. 4 over 6 is 2/3, already have that. 6 over 6 and 12 over 6, I already have those. So that's my whole list of numbers there. So then we do the same thing, plug that into your calculator and see which ones of these look like they could work. All right, are there any values that look to you like they could work?
My calculator's still loading it.
3 halves.
Mine's just
Negative
loading.
4/3.
3 halves, negative 4/3. All right, so let's check those and see.
How long is it normally supposed to take for the graph to load?
I mean, it shouldn't
Mine's
take
taking forever.
that long, but did your other graph load quickly?
Yeah.
Okay. So I was gonna say if you still have a stat plot on or something, that could be why. But if your other one worked, then you don't have one on. I don't know. Sometimes it just like freaks out and then it freezes and then tries again. All right, which one do y'all want to try first?
Neither.
3 halves.
3 halves.
All right, 3 halves. I'm not missing anything, so I'm good to just copy the numbers down. All right, bring down the 6 times 3 halves is 9, minus 1 is 8, times 3 halves is 12, minus 6 is 6, times 3 halves is 9,
Why
minus...
is it not negative 3/2? Because that's what
Another
it was on the
cookie.
graph.
Because on the graph, it's on the right-hand
It
side.
was positive on the
Okay,
graph.
I thought we switched this out and we put it in synthetic division.
Not when it's already given in 0 form. In factored form, we do. But when it's like this, we just use the sign that we see on the graph.
So if you said x minus 3 halves, it would be just 3 halves, right?
Yeah, 3 halves is what's going in there. And then 8 times 3 halves is 12. Minus 12 is 0. So this one is good. So 3 halves definitely works. Now, you can either continue using the original equation and go through and do the negative 4/3 under the original. But since I've already confirmed that 3 halves was a 0, I can actually just continue on with these numbers here. So I can do negative 4/3, and then I can just do 6, 8, 6, 8 on that. So, bring down the 6 times 4/3 would be negative 8. Somebody lost a minute. Plus 8 is 0 times negative 4/3 is 0. Plus 6 is 6.
Negative 8.
So then we get negative 8 and ultimately then 0. So that means that that also is a 0. So both of those are zeros. And it only crosses twice. So I have that. So those are the only 2 real zeros that go with this one. All right, the last stuff in this section, I know there's a lot in this section, is to use synthetic division to prove that the number k is an upper bound for the real zeros of the function, and then same thing but lower bound. So, 40, k equals 3. F of x is equal to 4x to the 4th minus 6x cubed minus 7x squared plus 9x plus 2. So we use synthetic division if all of the numbers across the bottom, when I work this out, have the same sign, it's an upper bound. If they're alternating non-positive, non-negative, and the reason we say that is because 0 obviously can still be, part of that. If they're alternating non-positive, non-negative, back and forth, then it's a lower bound. So in this particular problem, they're telling us to prove that it's an upper bound. So obviously we can plug that in, but if I just asked you to tell me if it's an upper bound or a lower bound, that would be what you'd have to do.
Like upper and lower in correlation to what?
Like on the graph, like it's the highest that it can go.
So we're proving that 3 is the highest that it can go?
Well, like that's where the upper bound would be like occurring, essentially.
At y equals 3?
X. Because it's a 0.
So would you be able to find this out just by graphing it?
Yes. But that's not what the instructions say to do. So 3, and then we use all these numbers. So 4, -6, -7, 9, and 2. And same rule applies if anything was missing. Bring down the 4, times 3 is 12, minus 6 is 6, times 3 is 18, minus 7 is 11, times 3 is 33, plus 9 is 42, times 3 is 126, plus 2 is 128. So all of these are positive, so 3 is an upper bound.
It's an upper bound because why again?
Because these are all non-negative,
Okay.
technically, is the official phrasing.
What if one of them was 0?
It doesn't usually happen that much, but I'm pretty sure as long as it's just not negative, then it's fine.
Okay.
Or like, I think technically if they're all negative, it's also fine, but you typically only see them all being positive. Let me look really quick where that is in here. Yeah, positive or 0 is fine. And the catch with this one is k has to be positive, or well, it has to be greater than or equal to 0. For it to be a lower bound, k has to be less than or equal to 0, and it has to be alternating non-positive, non-negative. So that's the other catch there to determine. So I mean, they're obviously like, other than 0, they're basically completely opposite. So you'd be able to kind of know what you're looking for right away. 44. K is equal to -4. F of x is equal to 3x cubed minus x squared minus 5x minus 3. So we put -4 here. And then I've got 3, -1, -5, -3. Bring down my 3. Times -4 is -12, minus 1 is -13, times -4 is positive, thank you, 52, minus 5 is 47, times -4, 188, but negative. Minus 3 is -191. So this is positive, negative, positive, negative. And again, zeros can work in there as well. So -4 is a lower bound.
So we only swap the sign of our k
If it's written in this form, this factor would be x plus 4.
Okay.
The 0 is -4. So k is the 0 that it's giving you.
Okay.
If you ended up with 2 zeros next to each other, would one of them count as a negative and one of them as a positive?
I was actually just thinking about that in my head. I don't know if I've ever seen that. Let me see if it addresses that in the book. Because I honestly am not 100% sure about that.
That makes sense because it's one non-negative and then one non.
The numbers in the last line are alternately non-negative and non-positive. I would say that it's fine, but I honestly can't think of a time I've ever seen that happen.
Okay.
Oh wait, here's an example in the book. Let me check. 0 is a lower bound. Positive, negative, positive. Let's see. All non-negative numbers, one is upper bound. Yes. So if there are zeros back to back for this part, for this one, it is fine.
Okay.
Yep, that is classified as non-negative, non-positive still.
Okay.
Yeah, I'm glad they put an example like that because I honestly don't think I don't think any of them are gonna work out that way, but that way you would know if it does, yeah. Alright, problems. Now, I will only be in class for like 15 minutes tomorrow and then I have to leave. So you're gonna have like all of class tomorrow, so when I give you these problems, don't be like overwhelmed by the quantity of problems I'm getting ready to give you. Because it is kind of a lot because there's a lot in this section, but you have all of tomorrow to work on it. So 7, 9, 13, 17, 19, 21, 27, 29, 33, 35, 39, and 41.
You said we should do this in class
Yeah.
tomorrow?
Yeah. And quiz Friday.